I'll start that again. So welcome to Nick and Rob. We had a presentation from two of their colleagues last week in Ireland. I haven't fed back to you guys. They said that was just a fabulous session.
Great, because this one's different. It will be different.
I'm expecting equally good things from you guys as well. So without further ado, in your capable hands and good luck.
Lovely, thanks, Mike. Good afternoon, everyone. Just put it out there, I am not a rigger. Okay, never have been, never will be. But I want to just let you know where myself and TMS, Texas Marine Supplies, actually fit into the whole rigging game. One second, please. There we go. Thank you. So TMS was founded almost 10 years ago as a trade distribution arm of Allspice Master Rigging, which is our rigging link. So we can call on 20 to 25 riggers for their knowledge, advice and support at any one time. We represent the Hammer brand across the whole of Europe. So Hammer Global is the largest consumer of stainless steel wire rope from COS, Korea Original Stainless. So we get through a lot of wire as a business, whether we're supplying spar builders, OEMs, riggers, non-marine applications as well and industrial. So we do a lot of wire rope, and we've designed our fittings to complement the wire rope we do. We're also a proud member for 5 years of the BSSA, which was a rather extensive exam to qualify for. But it gives us a lot of knowledge about the different types of stainless steel that we're working with in the field. I have brought some fittings here for those in the room, and we can look at those over lunch. Some failure fittings, premature fatigue failure, just to let you know what we see in a fatigue failure in the UK. So usually the wire is swaged inside a fitting. The swage machine is quite important. This is looked after and serviced. The beds can wear, and they'll quite quickly tell you if it's not swage tolerance. We do tolerance tools as well. Important thing to note on this is when you see the fold line on the swage terminal, the creases should be down either side. We don't advocate rotating the terminal and having a second swage. Some manufacturers do that, and that's absolutely fine because they do it in-house and it's their tolerance. But in the field, we advocate a double swage, but you don't rotate the fitting. So what that can do, it can open up the swage, allow moisture in, and in Southern Europe, that promotes crevice corrosion we often see in those different climates. In the UK, we don't really see crevice corrosion. We see fatigue. So we see failure from fatigue rather than crevice corrosion. My Greek customers and Turkish customers, where it's warmer climates, they tend to see crevice corrosion being a cause of failure more than fatigue. And our colleagues in Australia very rarely see fatigue failure at all, purely because their insurance companies stipulate the rig has to come out in year 10. So most boat owners will remove their rigs at year 8. So different fittings on the market, swageless, mechanical fittings. So the Peterson High Mod and the Staylock products are the most popular. We don't see huge amounts of these anymore because they're very good quality product and they last a long time. They can be opened up for inspection if need by a qualified rigger, but the cone must be replaced every time it's opened up. And the former in the High Mod version needs to be changed as well. They're a really good solid bit of kit, and for somebody doing blue water cruising, to have a spare wire length and some fittings means they can do underway repairs if need be. Very strong, suitable unit, and they last about 2 wire cycles, provided we change that cone and that former in there. So what are the key things that's going to cause the mast to fail? So it tends to be the standing rigging that lets go, whether it's wire, rod or composite. We're mainly focusing on wire, but we are going to look a little bit at the rod fittings and what we look for when we're looking at those. We touched on before, it's mainly fatigue failure that we see because we really like to push the rigging, or customers like to push it as much as possible in this country and in Northern Europe. So if we look at the first picture on the left there, we'll see a typical fatigue failure. That is fairly common indicator that the whole rig standing rig needs to be replaced. The right-hand picture shows, and also the centre picture shows crevice corrosion, where at a molecular level the water's actually got in. Again, it's condemned, it needs to come off. The second picture shows you a low quality stainless steel product from a different continent. And when you have crevice corrosion going horizontally across the fitting, that is not normally through water ingress from being fatigued and worked. It's normally because it's a poor quality stainless steel that's been used. Again, must come off. The fourth picture is a T-terminal, and there's different shapes and sizes of these. The Navtec and the Hammer ones have a swollen shoulder, just because that's where the most fatigue happens. Again, the only way you're going to see this, and I've actually got a piece of one over here to look at. The fatigue started with crevice corrosion, a little rust stain on the inner shoulder, and you'll never see that while the rig is up. So when that rig comes down at year 5, 6 for a little birthday, that's what the rig is looking for. They're looking inside the components to see actually what you can't see when the rig's up in the air. And that would lead to complete and utter failure. The rig would literally fall out the sky. And the last one is it's misalignment. So it's when you look at a stem ball, there's many different diameters of heads and radiuses, and they should really fit in the right socket. If that's not done properly and they're mismatched, when that rig is tensioned, we can have severe misalignment. And what we're going to do is we're going to massively load up the wire at the point it goes into the fitting, and that will then cause premature fatigue failure like we see on the left. In the UK, we say 30,000 miles, typically, or 10 to 12 years is the service life of the rig, but there's so many variables in there as well. So we want that rig checked every 5 to 6 years by a professional rigger. And if you're pushing the 12 years, then you're moving into borrowed time. The 30 years is based on the rig being looked after, maintained, tuned, and tuning is a big aspect of lifespan of the rig. If you put a new rig in the boat and it's tuned by a professional rigger, and we let that boat go around and do 1,000 miles of sailing, let's get that boat back in, let's get the rig on board, check the wire tensions, retune it, because there is constitutional stretch within the materials, and that needs to be allowed for. We'll see that in the first 1,000 nautical miles, certainly. Raise a point on the bottom line here. Some industrial products and Chinese products are very, very different in terms of quality. So the swage fittings aren't always drilled 11 times the diameter. They're not always drilled with a gun drill. The radius aren't the same. And we do see quite a few premature failures from substandard quality or substandard materials being used. There are some manufacturers out there as well that actually buying component products from China to actually make their full assembly. So we really need to be aware of that. And we've got a toggle over there actually, which was supplied with a brand new boat. The rig was installed. 3 weeks later, boat being commissioned with the rigger and the broker, and it failed inspection after 3 weeks because we had surface corrosion on 316 stainless steel. That boat builder, through pressure of the broker, replaced those fittings with a different brand. So we really have to be conscious of what we're looking at and pay attention to this. Any questions so far? Because I know that I'm firing on, because we've got to give Rob from Marlow a little chance here as well.
Is Chinese manufacturer a red flag all round, or is there items made in China that will fix it?
So our fittings are made in Thailand in a Western factory, Ben runs, and they are very stringent standards, and they only deal with 316 and duplex in that factory. The problem is we don't know. It's similar to certain wire manufacturers who use different formers to run galvanized wire and then stainless the following week. And that's when sometimes we see that wire strand changing. Good question. I have yet to, we don't deal with China at all as a global brand. We come up against it a lot. Yeah, I can't advocate them, I'm afraid.
So just go back to what you said about you see that wire strand changing.
Yes,
You're talking about down the rigging.
that individual
You've seen
strands, yes.
Yeah, I've seen quite a lot of that.
So that's normally when at the mill they use the same dies and formers for a galvanized wire, and then the following production cycle they might be making 3160 wire, and it's contamination.
Right.
If you see it in one strand, it's going to be contamination from
And you
manufacturer.
have to write that off then.
You'd have to get a professional rigger to come and assess it, but yes,
Basically,
ideally,
yes.
because that is a structural component which has already got corrosion embedded into it.
Right.
Autosol, try and give it a good clean off, and if it polishes up and removes that contamination, then it's surface contamination, it's not internal. So that'd be the first step. Because we often see tea staining and it just needs a good clean. It's the greases and the oils from manufacturing in a container with different materials stuck to it. And when the rig's put up, it's wiped down, then we got surface contamination. So you need to really check it first and make sure it is structural, not just on the surface. But yeah, good point. Going to look at rod rigging very quickly. So we work with a brand called Nitron 50. We think it's the best rod you can get. It's BSI product. It's very well polished. It's a nice surface. It's smooth. It's clean. It doesn't attract contaminants. You will see rod rigging more and more, and not just in the race boat market. You can see this on some blue water cruisers. The benefit of rod from an owner-operator point of view is you get a much higher MBL, much higher minimum brake load than you would with wire ropes, so therefore you're saving weight out your rig and keeping the weight down below. These are not swage, these are put into a rod press and cold formed with a socket on there as well. They should last a lot longer than wire rope, but they need to be regularly serviced. So again, 4 to 5 years, take them off, degrease, dismantle. If the heads are gone, we'll look at some different head sizes. If there's some issues with the heads there, they can be cut off and reformed, providing there's enough adjustments in the rig. It's a great material, but it has its limitations in terms of what you can do when you're cruising and you need to do a repair.
Most insurance companies say that the life of rod rigging is actually shorter than the wire rigging.
And some surveyors say completely opposite. Yes, you're right. Or some surveying bodies say completely opposite. It depends how it's used. If you're on a race boat, we're looking at 5 or 6 years and it's running its service life. And it'll come down to mileage. And there are so many variables with rod, depending on its application the boat is fitted to. There is no hard, fast rule that we can apply like nautical mileage like with wire rope. Every situation is quite unique. And all we can say is it just needs to be maintained and cleaned and looked at more intensely, especially on a race boat or a heavily loaded blue water cruiser than the wire rope.
And you're saying 4 to 5 years, mast down, bring
Yep.
it off, check the board.
I think in the guide on the table as well is we're advocating 5 years, get the rig down, give it a birthday.
I've got a question from online from Kim. Do you get a certificate of origin for wire when fitting new rig?
Sorry, can you repeat that, sorry?
Do you get a certificate of origin for wire when fitting new rig?
Good question. So we issue with every single, so we buy the wire 1,000 or 3,000 meters, we remill it in house to a workable amount, say 200 meters. Every single product we bring in is fully traceable with a milling certificate. So it's the exact chemical composition of that wire rope, which is batch ID. We issue that with all the wire we supply on the reels, and we would like to think our riggers then put that in the vessel's handbook for the client to keep hold of. We are also moving forwards to add a purchase order numbers laser etched into our fittings from 2025, so we have full traceability on those as well. It's a good question. Short answer is yes, we do. And only 1 or 2 global manufacturers of wire rope will offer that information. There's a very clear indication of what you're actually buying. So thank you. So jumping back to rod again, this is how it's formed in the rod press. You can see the 2 jigs with the rod bar coming in. Center picture there. We're just lining up between the 2 jigs, then we bolt them down. And then the hydraulic press pushes forwards, forms that head. And in the bottom right-hand picture there, we can just see how the cold forward head is. And so we've got some examples over there. Normally you've got to knock the jigs open to get them out. There's a lot of pressure in there. And you can do that up to about inch bar down in Plymouth. And then different examples of fittings, sockets, the toggles, and the cups as well. Again, these are all dismantleable. You'll see that they're not mechanically swaged together. They are loose, they do turn inside. So they can be disassembled, cleaned, re-greased, put back together again. And just talked about the benefits earlier. Easy to inspect, fully serviceable, and much stronger with that less weight aloft. Just a few pictures here of rod failures. So the one on the left here, if we look at that picture right in the centre, I'm going to lean across and show you just here. There's a little crease from the two jigs. So ideally, a rigger, when they make that head, would then cleanse that little crease off so it's nice and radiused. The second picture in is the jigs haven't been aligned properly. So that's canted, and that will put extra stress on one side and cause premature failure. The middle one, it's not been tuned properly, or it might have been in day one, but then it hasn't had a chance to settle in, and they're chattering marks. So what that tells us is it's maybe the lured one is moving a lot when the boat's on the way. Again, that will cause a premature crack in the end there for whatever reason. That needs to be cut off and redone. That's not acceptable. And then on the far right hand side, a picture of a fatigue failure of a rod head. Actually, it started on the top, crevice corrosion settled in, and then we've had complete failure of that one. So this is a statement for Hammer. We give this when we do our rigging training programs to all our riggers. And it's just, if you want to take a moment to read through that, it's just where we stand on things. There is no time on there. It is 10 or 12 years. But there's so many variables. That's why no car manufacturer will give the same warranty. So we say 10 to 12 years, but it needs to be checked periodically. When we look at the statements in there, the second line down, load path, that's also very important. So in the UK, we talk about changing the toggles as well as a complete forestay. If it's in the load path, then it's under the same loading throughout its life whilst that rig is up. You can slow the clock down by taking down your rig, but once it's installed, the clock is ticking. Chatting to our Australian peers who represent Hammer in Australasia, and they had a boat come in with the stemble in the cup for the V1s, and the stemble wasn't changed. And they're rolled threads on the stemble, very strong threads, and that's stripped the threads and then lost the rig. Completely rig, but that one stemble wasn't changed because they're not the easiest to do. So it is the load path which we highlight, and that is really quite important. And 30,000 miles, if the rig is tuned, is easily achievable. So our conclusions, replacing the rig in a timely fashion is important. 10 years or 30,000 miles, I say we go to 12, past 12, you're on borrowed time. In Australia, as I said, they rip it out at 10 years, but it is so personal to how the boat is being used. And the only way you get a good view is to get someone who knows what they're doing on the boat and do an inspection. Tuning of the rigging is massively important to get that lifespan. And not overloading the boat. I know our colleagues at Allspice spoke last week about blue water cruising when you end up putting 2 or 3 ton extra on the boat because you've got all your provisions on there. Well, that boat wasn't designed with the righting moment to be 2 or 3 ton heavier. So do you consider having resizing of rigging to take those loads? There's a lot of thought going into the structural loads that a mast is designed for. And when we as boat owners decide to change that, we are playing with the unknown. And statement there that a mast should last 30 to 40 years, looked after. And the way we look after it is not let it fall out the story. The tea staining is an indication of 3 things really, so we should look out for that. Normally you can clean the tea staining off. If it comes back, it's definitely a problem there. So it's either you're someone in a commercial harbour is grinding near you and you've got external contamination. Good indication, especially if it's on the port side, not starboard, would be an earth leak and a live current. That's a really good indication you've got an electrical issue, or it's a poor quality product. And they're really the three causes of teeth failure. So we reckon and advise that masts and rigging checked every 3 to 5 years by a professional rigger, and annual visual inspections, which is part of any cleaning and maintenance guide for your rigging. I am conscious we've flown through, it's a massive topic. We are available to support and advise on our products and other products in rigging. Andy of Allspars, who founded the business nearly 30 years ago, he is more than happy to be at the end of the phone or email. Mike, you've got Andy's details and mine, please do share them. We're always happy to take a question, and we will always help and assist where we can.
Thank you very much. Can I make a point? It's not a question really. We read in various rules and regulations about competent persons. There is no, as far as the best of my knowledge, there is no formal certification for riggers.
I know, yes.
So you can say, I've been a rigger for 30 years. That doesn't make you competent.
You've just been doing it badly for 30 years.
Doing it badly for 30 years. I mean, I struggle with this stuff. So I mean, is there anything you can say on that?
I completely agree with you. All we can do as a representing the manufacturer of the brand is to share our knowledge, and we're doing TMS one shared training days with various rigging manufacturers. We've got 2 more coming up, I think, in July. And all we can do is make sure that we give as much information to our rigging community and our rigging customers. And for me, I travel with Europe doing exactly that. But I think you're right, it'd be lovely if our rigging federation could get together and put something together. I think, it's been talked about for a long time, but it just takes somebody to actually do it and implement it.
How many riggers are there in the world? I mean, it's a silly question.
Thousands. Yeah, there are things coming later this year as well, which will just put a bit of definitive questions on some of the answers. Answers on some of the questions that we're being asked, and that will be publicised probably by Q3. So it will certainly help yourselves and insurance companies in deciding whether or not that rig should stay up or not.
Yeah, brilliant.
Okay.
Any other question?
Yep.
Are your bottle screws, are they made from 316 or are they plated glass?
Chrome plated bronze. Yep.
Not stainless.
Yeah, fine. See, a closed body stainless bottle screw, personally, I don't like because you don't know what's going on inside. An open body one in 316 tube we're seeing now because aesthetically they're nicer. Quite a few new boats are coming through them on pipe screws, as I class them as. As long as they're 316L and they're gone through the testing, not a problem at all.
And the bottle screws have the same 10-year life as all the rigging, or do they not need to be changed?
Again, that's purely down to inspection. You can't on the bottle screws. We often see them being reused, but I'm not saying we'd see that on a 15-year-old rig. So again, it is down to inspection at the time. There are some out there which are the chroming isn't as good as others, which takes away that protective layer very early on. So it's a good question. It's one. It's very personal to the boat, definitely.
I think it's also getting to people's lip service to the insurance requirements, because they say that you have to be rigging in 7 years, and they don't want to do that as cheaply as possible. So they turn down the bottle script. And that's often done 2 or 3 times. Usually,
and then we talk about the load path.
Yeah. But if you're not going to put a prescription on that, then just slow it down to inspection. You not quite frequently see failed rigs with the straps on the bottom taken.
And we are concerned that how many people don't change a toggle or the extension link on the bottom of a forestay when they put a whole new forestay on, which is why we go back again. Load path is critical. And that's what we're talking about here.
I understand the point that people are only changing their rig because the insurers have told them.
Yep.
And to follow on from that, then we have the anomaly with some insurers saying, to a client, we're doing a condition survey for insurance. And, you know, we're cutting the official line in our survey reports, and the insurers have turned around saying 15-year-old, yeah, fine, just get a riggers report, we'll be fine with that. And it's making it undermining what we're trying to do is.
We are working on that we are working on that. And by the end of this year, there'll be something that makes, I would like to think, life very easy for surveyors and insurance companies around the globe.
Yeah.
It reminds me, sure, the insurer said goes 10 years, how a rig check is going to be all right. The rig check is done and various areas, for instance, underneath the furthers, but got to or excluded because they can't see them.
Yep.
The rig fails in 3 months' time, exactly where the rigger said he couldn't see, and the insurance still paid that for the rig check.
But when we take our vehicle for an MOT test, it's perfect for that time, but a week on Thursday, who knows?
Yeah.
And it is, and that's what we're exposing ourselves to. So it's,
So you're in an area that wasn't checked, but it's still paid for by the insurance. Because you have rig check. Extraordinary.
yes. So, any more questions online over there?
Not the moment, thank you.
No?
Lovely. Well, as I
Thank you very
said,
much.
thank you all, and I'm pass it off.
Handling seamlessly here as well.
Yes.
Welcome, Rob.
Thank you. Yes, as you said, this presentation was done a week ago, created by somebody else and presented by somebody else. So this is my attempt at it. So I may compromise presentation quality just to get the information across. Yeah, just as Nick did with TMS, there's a little bit about Marlow Ropes. We're based in Hailsham near Eastbourne. There's a team of 70 people on site. And in fact, rope has been made on that site for over 200 years. Rope even features in the coat of arms for the town. So you'd like to think we've got a bit of experience in what we're doing. And we are conscious that within rope, it can be a bit of a daunting subject to try and get your head around and a bit of a mystery. Don't worry, it remains so. The idea of this presentation is to give you a little bit of background about rope, where we are right now with it, and obviously then some sort of a picture book, if you like, of things to kind of look out for and be aware of. So start with what is rope on board. It's what my colleague David calls the key connection. So obviously you've got your sail controls, that's all your settings, that's halyards, outwalls, Cunninghams, kickers, and then boat speed and handling, where you're moving towards your sheets. That is that's the most direct connection the sailor has to the boat, to how the rope handles, how grippy it is, etc. That means once you've got those sail controls all set up, how you can use that to safely maneuver the boat around. And as I said, the third bullet point does link to the other two quite well, but that more revolves around owners, as you very helpfully highlighted. Owners will scrimp on the most important parts of the boat, and ultimately quite a lot of the time our most prized possession is tied up to the dock with the cheapest thing available. So this slide gives everyone a bit of an idea as to what we're looking at nowadays with regards to sheets and lines on board keel boats, anything bigger than 25 foot, really up to sort of 60 foot. This is pretty standard fare. So down at the bottom there, you've got a polyester double braid line. Okay, now with the improvement in polyester yarn that's available nowadays, as well as what we as rope manufacturers do to the rope once it has been braided, you'll starting to see better performance and longevity from that entry-level product than ever before. Now that's what makes this double braid line a bit of a staple amongst riggers such as all spars. It's probably the line they use the most in the most applications. Now, most polyester-based ropes share the load 50-50, broadly speaking, between the core and the cover. Okay, so that is the case with double braid rope. So, from a marine surveyor's perspective, that means if you're seeing any compromise of that cover on the rope, it's starting to affect the load holding capacity of it. Okay. Now in the middle there is a Marlow braid, it's a pretty old, famous product of ours. That's got a twisted 3-strand core. And historically, it has outperformed double braid with regards to stretch. And so historically, it has been a racing product. But we are, for the reasons I listed just now, seeing double braid start to catch up a little bit with Marlow braid. So you'll see less of it around. Now, at the top is what a lot of the rest of this presentation will focus on, is kind of the last quantum leap in material availability in the rope world, and that is a Dyneema cord line. Now, confusingly, the jacket looks exactly the same as its double braid cousin, but on this line, because of the load holding capacity and stretch characteristics of Dyneema, all the load is held in the core. Okay, so the jacket at that point is purely selected for the properties in hand and on hardware, and obviously for a bit of protection. Does that make sense? Now, these slides kind of illustrate a little bit how things have come along with regards to the use of Dyneema on board. Now, it is this magic material that people are discovering more and more uses and applications for. One of the best things it can be used for, it loves being lashed. Okay, so because obviously we all know Dyneema for being very strong and low stretch, it is also slippery. So it's very easy to put multiple laps on, put half hitches in the correct way, and then as it beds in, it evenly distributes the load across all of those laps. Okay, so on the left-hand image there is actually in the middle the forestay of the clipper boats. So they're terminating their forestay with the Dyneema lashing. And interestingly, at the end of the race, or sorry, halfway through, we replaced these lashings, and we're finding that those old lines are 20% stronger than they were when they were first fitted. Now that's because to provide a bit of context on how a rope is made, first you twist flat yarn in 2 different directions. You twist that together to create your strands, and then you braid it. And then at the end, either go straight into reeling out to the customer, or you do things to it such as pre-setting and pre-stretching and heat setting. So what's actually happened on that forestay is that process of pre-stretching has continued and the fibers have aligned even better. Now, what we start talking about now is, for this presentation, is Dyneema's use in standing rigging. Generally speaking, Marlow Ropes don't really recommend it quite yet as to be used in standing rigging. That said, at a small scale, riggers, etc., are playing around with doing so, and we help them when they ask us for it. It's not something we're actively pursuing. There are fundamental challenges with using Dyneema in standing rigging applications. Much of the hardware isn't designed for use with Dyneema. Similarly, if you were to look at a forestay or a shroud on a monohull, you're going to have spinnaker sheets and, well, you're going to have Genoa sheets and or spinnaker sheets quite often zipping along. And if you used a stainless steel product, that's not going to be a problem. But another feature of Dyneema is that it doesn't really like heat. Okay, so not only is it a textile and will naturally wear away sooner than stainless steel, if you're zipping a line along it, it will also heat up and degrade that way. So it's a difficult challenge to come across. Now, that said, there are riggers out there who have used Dyneema for standing rigging. If you come across this, I mean, like Nick said, I'm not a rigger. I can't really tell you what to do. But we would probably suggest finding out how long it's been on there, who did it, and then finding a specialist to have a look as well. Okay. This kind of gives another example of the great diversity of uses that Dyneema offers because it's such a workable product. You can splice it into all sorts of soft applications. Now, Dyneema is fairly UV stable as a product. And if it's cared for properly, protected correctly, and left out, you can see up to 10 years of safe use before UV becomes a factor in its degradation. Okay, now naturally as a textile, it's a braided product. So you've got the fibers on the outside and you've got the fibers on the inside. Okay, and generally speaking, we're all working within quite safe tolerances of the loads that are advertised. And so actually, even if UV has affected the outside layer of fibers, the ones on the inside are still doing the job. Okay. To give you a bit of context as to the temptation to use Dyneema in these applications, that image on the left is a 2.4 meter, the sort of the small keel boat that you sit within, single-handed, very tiny. David, my colleague, worked with someone on replacing all the stainless steel rigging, standing rigging on this boat, and they drove 2 kilos out of it. So the temptation is there, and obviously that has ramifications in the cruising world as to the potential benefit with regards to listing, motion, and performance. On the right-hand side is a multi-hull, where the use of Dyneema is slightly more commonplace. You've got the room to do these lashings, and the Genoa sheets, etc., tend to sit a little bit further away, a safe different distance from the stays. Now, obviously, it's not compatible for use with headsail furling gear, for example, so you need to be a little bit careful. Similarly, on multi-hulls, you don't tend to have spreaders to contend with, etc. So it's a little bit more straightforward. Now I'll go back actually. With regards to using Dyneema in standing rigging, unlike the products Nick was talking about, you obviously, with it being a textile, you have some form of stretch and some form of creep to contend with as well. So I won't go into too much detail because we're trying to rattle through this a little bit, but those are the considerations that a rigger doesn't have to contend with when it comes to stainless steel fittings compared to the methods of practice with regards to Dyneema. So, hope that was a bit of a crash course on the ropes you're likely to see on board. Now, what I haven't spoken about are dock lines and anchor warps. It's fairly simple. Fundamentally, you tend to see 2 materials used for dock lines. You've got nylon and polyester. Nylon is more stretchy than polyester, but it is less UV stable. So quite often you'll see nylon used for anchor warps, and people revert to polyester for the dock lines, etc. All right. Now, these images give a good example of what you're looking for when you're inspecting Dyneema. Now, that image towards the top and in the middle is a fairly straightforward one. That's a broken strand. Broken strands mean less load able to be held and possibly something snagging or catching on the line at that point as well within its motion. Okay, in that example in particular, I've got a better slide later on that shows this kind of damage. That's a clean cut. All right, the fibre hasn't furred up at all. That's a clean cut, which suggests there's something sharp in the system catching it. On the left is something that's a little bit more difficult to spot. All right. Now, this particular example was for Team Concise, Big Mod 70, but the principle still applies. That line is from their canting rig system, where fundamentally a really loaded Dyneema line was going around a sheave repeatedly on the same section. Now the outside looks okay, but once you've opened the rope up a little bit, you'll see on the inside the coating that we put on the line in manufacturing has worn away, and therefore the fibers have started to chew on each other on the inside. So that's an example of internal abrasion on the rope. Okay. Now in this example, that was a highly loaded application, and was going to happen. But this is the kind of damage you can also see from contaminants within the rope as well. So sand, grit, salt, any nasties that may not have affected the outside of the rope, because that's fairly easy to be cleaned and quite often washes off with rain. But once something gets into a line, that's something to be aware of. Okay. On the right-hand side is what we call cold moulding. Now you see that there's something obvious going on the yarn, that you see the two braids in the middle that sort of towards the top have been pulled apart to look at the one that's going underneath. You'll see that it's gone a bit shiny. That's not anything to worry about. Okay, you'll see there's no actual damage to the fibre, no actual damage to the yarn. That's just where now on cruising yachts, this is something we see quite often where Dyneema or a cruising Dyneema line has been cow hitched onto a shackle for a halyard, and so it's been left under a fair amount of load for quite an extended period of time. If you see this, we generally wouldn't touch it. It's fine. There's no damage there. There's no need to unwork the cold moulding and put it back or anything like that. It's all nicely settled in. Okay. Any questions on that slide? Now we move on to cover damage and what to look for. This fairly commonplace and quite difficult to ascertain exactly what's going on. Now this is a halyard on a boat that does a bit of racing every now and again, and so the line is loaded consistently in the same spot, and you'll see that it's worn prematurely. You'll see the rest of the coil there of the rope. It's not actually very old, not even faded. The polyester hasn't even faded in the UV. Okay, so what's been happening to that rope is it has been slipping periodically when under extreme tension. This can happen quite often on boats where you go around the windward mark, ease the backstay, take the jib down, take the genoa down, and then before you get to the leeward mark, you put the genoa back up and apply the tension they think they need, and then they wind the backstay on after they've gone around the leeward mark, and it goes through the roof. Okay. Now, obviously, you need to replace the rope, but at every one of these instances, there's an interaction between the rope and the corresponding hardware. Okay, so what's happened here is it's actually stripped the anodizing off the teeth of the clutch. So what that does is it means the teeth are no longer uniform and straight, and they are not gripping the rope as the clutch is designed to, and that kind of puts a bit of an imbalance in it. But furthermore, as soon as anodizings come off a tooth, you're exposing the aluminium, which then corrodes and becomes like sandpaper. You're then, as a yacht owner, in a bit of a catch-22, because you see your rope wearing out sooner, you want to throw money at the problem and buy an upgraded line, for example, something with Technora in the jacket, which would probably make the rope last a little bit longer, but make this problem worse. The actual fix is probably to replace the cam within the clutch, and depending on the type of sailing the customer's doing, continue with a polyester jacket moving forwards. If they want to upgrade to something with a bit of Technora in, for example, Spin Lock, this is the brand we're talking about here, but I think Carver are the same. They offer a ceramic cam that you can upgrade and not have to upgrade the entire unit. All right. This slide shows what I was talking about earlier a little bit better. Cutting. So you'll see we've kind of unhelpfully used red as the line that we're drawing the cut lines on, but they're clean 90-degree cuts on the yarns there, okay? So in this instance, I think it was actually a bottle screw that had some burrs on it or sharp edges, or a cotter pin sticking out there, and or a piece of the standing rigging wire sticking out at the edge, and was slicing the rope in the same place every time. Okay, and at that point, it wasn't simply a case of replacing the rope; it triggered the need for a rig inspection. Now twist is one of the darker arts when it comes to diagnosing and figuring out, but twist causes weakness in the rope and it loads up only one section of it. It causes premature wear, and if the rope ever goes slack, you then get overhand knots and the obvious nightmare afterwards. Now, the most common cause of twist on cruising and racing yachts would be misalignment of hardware. Okay, so you'll see there on the left, the block that's got the yellow line going through it is too close to the block that's got the red line going through it and is not aligned nicely with the load of the line. And so that has nurtured a twist into the rope, and you've got the obvious consequence there. From a hardware perspective, you would also want to check the condition of that block. Okay, because you're going to see the sheave rubbing on the cheeks rather than the bearing purely in line all the time. Okay, the bottom left photo is quite a good example, and I think that's come out of a catalogue, possibly for Harkin, possibly for Geno or someone. But that shows that how brand new boats look nice, but you'll see that grey line is already nurturing some twist in it. Okay, and that may be caused by the hardware on the deck not being quite perfect, so that cheek block perhaps might not be quite lined up, but equally the pure action of winding and unwinding a winch can throw twist into the equation. This one's fairly obvious. The rope was burnt, it was melted. Now, in this example, the owner bought a boat that had been cruised or barely sailed before, sold it to someone who decided to jump into the evening series, and they're using the rope far greater revolutions, far greater load than before, and the polyester jacket has melted on the winch drum. Okay, that melted section can then crack, and fundamentally the rope is compromised. So at that point, they may wish to consider an upgrade, something with a bit more of the heat resistance, a bit of abrasion resistance, but be careful, because is their hardware designed for use with that upgraded rope? On the left, now cast your minds back to what I was talking about with double braid ropes. This is a double braid rope, and needs replacing instantly because that jacket, which holds half of the load, polyester double braid rope, has been compromised. Okay, in this instance, that damage has happened when the rope was slack and blowing in the breeze, and it was just knocking against a slightly open split ring. It's just plucked in a very specific place, maybe a bit further along at some point, plucked the jacket away and exposed the core. Okay. This final section kind of concentrates on knots versus splices. Now, traditionally, a cruising yacht would use polyester rope, and they may have had a knot tied in it originally, but even that double braid polyester, you can see, loses almost half its strength if it's just bowlined. Okay, now this is exaggerated when it comes to Dyneema, especially strict Dyneema. Okay, so the way that most manufacturers braid up Dyneema cores is in a 12-strand long lay construction, which doesn't like corners as much as that double braid did. Okay, so you have to be very conscious of the D to D radius that the rope's going around. All right, so if you think about it, if a rope goes around a really sharp corner, the outside fibers on that bend are doing all the work, and the inside ones are purely compressed. All right, so generally speaking, we're looking at about, we're aiming to get to about 2 to 3 to 1 on the bend radius of a rope. If you tie a bowline in your Dyneema core, you can imagine what that's doing to the bend radius. And you can see there that in testing, what it does to the load holding capacity of that line. All right, not to mention, recall what I said earlier about Dyneema. Dyneema is also quite slippery. Knots can come undone, you're going to see movement, etc., etc. From a yacht surveyor's perspective, I suppose the most relevant point here is obviously splices are better, but what we're trying to do as a rope brand is sell more Dyneema. And you're seeing a lot of cruising yacht owners upgrade their halyards, etc., from polyester to cruising Dyneema. Okay, now if they tied a knot in their old polyester halyard and gone to cruising Dyneema, you can go down a size, it'd be lighter, lower stretch, etc. But if they just tie the same knot in it again, couple that with age and environmental factors, the fact that you can reduce the load holding capacity of that rope that much by tying a knot in it, that's something to make the owner aware of. Okay. And this slide kind of talks about what I was mentioning there with regards to the D to D ratio, making your rope go through a bend. Sorry, we've got a question.
Oh, sorry, right, take one quick, yeah.
No problem.
Why do power winches cause high level memory twisting in comparison to hand winching?
Because to ease, it's quite difficult to explain, but quite often electric winches. Are you talking about electric winches that only pay in? That's worth checking first.
Not sure. That's
Okay.
all the information I've got.
The reason I ask is because there are some electric winches that pay out. So once you've nurtured that twist into the rope, you're then pushing it down the line as it pays out. With regards to standard electric winches, my only guess would be, Nick may have an argument for this, my only guess would be is that you can't feel the problem. Because you've got so much power with an electric motor, you just push the button and it pulls in. And quite often, and I'm stepping out of my role as a rope salesman here, but quite often you see problems with hardware, etc., because owner push button, rope come in. If you were you're pulling that rope by hand and grinding it by hand, you're more likely to notice a twist in the rope as it pays off, etc., or it gets in the way of your elbow. That would be my only guess. I don't know for sure.
Okay, what's this added? Genoa or halyard I have seen both.
With regards to twist,
Yeah.
Genoa or halyard? Sorry, can you repeat the question?
Yeah, apparently that was to do with the question, extra information, Genoa or halyard I have seen both instead.
So using the electric winch on the Genoa or the halyard with the seam twist, and I think, well, hit on the head, I think it's best not to both comes in, as opposed to actually manually looking after the riders and comes in, which we do naturally, rather.
Yeah. Yeah. Similarly, it's not just to do with what's happening at the winch. If there's misaligned hardware further along the line and you're using electric winch, you're not going to feel it. Whereas if you're grinding it by hand, you're going to notice an inefficiency slightly quicker. And it might not be the winch that's causing the twist. It may be the hardware further along the line. Okay.
Yeah, maybe the answer is the question, yeah.
Hopefully. There you go. Okay. On strength and load, we're a savvy bunch, us rope manufacturers. We all publish the load of the rope in different ways. Marlow, I can't speak for other brands, but Marlow published the spliced load of its ropes. And there you go. This is quite a nice slide. The only disadvantage from your perspective is it uses our brand, our product names. Double braid is colloquially known as a braid on braid polyester. Marlow braid, I spoke about Marlow braid. There are other products that are similar out there. D2 is our Dyneema cord rope range. So remember that red rope you saw earlier with the Dyneema core? That's part of our D2 range. And then D12 is pure 12-strand Dyneema cores. Okay, so that provides a little bit of context for you. There is this information and more on our website. Be worth having to hand so that you can kind of make owners aware of these principles. You look hungry. There you go. That was fairly short version of what David did last week. I think that version's on YouTube anyway, isn't it? So that's slightly more in depth. He's got a little bit more experience than I do, and it's his presentation. Does anyone have any questions before we head off? Sure, sorry.
During a typhoon in Hong Kong a couple of years back, we, in the insurance claims afterwards, we noted that 90% of the boats that broke adrift, we were using black mooring lines. Is there black pigment or anything more susceptible, or is it?
Only from a discoloration perspective. So UV degradate, most of the yarns, most of the ropes are treated for UV exposure, and the colour of the pigment in polyester, for example, which is likely what we're talking about here, doesn't actually make much of a difference to the degradation of the rope. That may have been due to fashion and popularity of black rope, or the fact that there was more out there. We do see fading more regularly on your reds. For example, they turn to pink, or pink, obviously, orange, lime. They will fade more readily, but the actual quality of the polyester isn't affected. Blacks, greys, reds, blacks, greys, greens, browns, they'll look better for longer under direct sunlight, but the yarn itself isn't really compromised. Okay.
Awesome. A rope that's being tapered, Dyneema rope, Dyneema cord rope, does the Dyneema that's inside have the same UV resistance as jackets? So once you've taken the outer off and you've just exposed the inner Dyneema core, is it still UV resistant?
Yes.
Yeah.
You've just realised. You just made me realise I didn't say a fairly key thing. So at the end of the Dyneema itself is a fairly UV stable yarn when we buy it from the supplier and get it to us. We as a manufacturer then PU coat it as part of our heat treatment process at the end, and that is a chemical reaction with the fibre itself, and that isn't going away. Anything beyond that is coloration. It's extra PU on the outside, and that can wear away, but that doesn't really affect the UV resistance of the yarn. The core,
the same as like a standard Dyneema without the same material.
No, so most of the time you'll have a polyester jacket or a polyester Technora jacket, which is a different material altogether.
Yeah, but if you took the core off, Dyneema cord, right?
Yeah.
Took the core off, is that piece of
Polyester.
Core, the Dyneema core?
Yeah.
Is it the same as a piece of Dyneema you get without a jacket?
Oh, sorry. Yes. Yeah.
In line UV resistance, everything.
Yes.
Exactly so.
Yeah. Sorry, I misunderstood the question. Yeah. So if you look at our factory, it's a little bit of a complicated situation. We sell cores and we sell ropes we sell Dyneema, covered Dyneema core ropes. So they go through manufacturing and either turn right to warehouse, or they go back through exactly the same thing for overbraiding.
Sorry, and a bit further. How do you, if we've got 2 bits of rope and you don't know what they are, how do you tell whether it's Dyneema or polyester?
It's not easy. It's not easy. And if you're unsure, you can ask.
Is it one floats and one doesn't? Or
Dyneema floats. Yeah.
does polyester doesn't?
No.
Does that?
So that's an easy test, but I don't know if the owner will be happy with you throwing their ropes and see. A cheat code is most brands have a distinctive pattern on any jacket, for example. So even if I'm not in front of the rope and I see a picture of it from a distance, unless it's a copycat product from another brand, I can quite often confidently say that's that product. There are different feels and appearance features of each product. For example, Dyneema is quite shiny. Technor was quite dull, but they're both
One
black.
person, one doesn't, isn't it?
Sorry,
Dyneema doesn't, no.
Dyneema melts. Yeah, Dyneema's got a very.
Like straight, not the end, doesn't melt in the same way, or?
They do have different melting temperatures. Dyneema melts quite readily, but Technora, for example, its main attribute is that it's heat resistant, so that doesn't melt. But from a distance, they might look the same. You can get them both in black, for example.
Just thought it was worthwhile you offering a couple of short lengths of D2 club, D12,
Yeah,
Marlow grade and double grade for anybody who wants them, just so you can feel the difference and you're confident then what you're looking on the boat. Because Dyneema will feel the same regardless of who's made it. And if you've got a reference to Marlow what Dyneema is labelled, it doesn't maybe what.
that would be very handy. I'm happy to do
I
that.
wrote that blue box.
Yeah.
Take the bath, wouldn't it?
Anything else, guys? Well, thank you very much indeed.
Pleasure. Thank you.
And thanks to Nick as well. Interesting session.
Leave the same fittings over there.
Yes, there's some fittings to look at. So we're coming up for 1:30. Shall we just make lunch 20 minutes? We're a bit behind. We'll condense the coffee break. I think or tea break. We put 20 minutes in for tea later. We'll condense that to 10 minutes and get back on schedule. Thanks ever so much, everybody. So let's be back at 10 to 2 UK.